So we're going to start working on expressions. And so the name of our packet is Relationships Matter, and we're going to be also working with relationships and numbers. Our expressions have to be related. So if I said the expression 3 plus 5, we know that is the same as 8. So let's get started here. We will take a look at our learning goals. We're going to interpret a number raised to a positive integer power. So we're going to be learning about what that is. Identifying perfect squares and perfect cubes, writing numeric expressions, modeling numeric expressions, and then evaluating them with the order of operations. So that's a lot of business, but we're going to take one step at a time. Our actual learning target is evaluating algebraic expressions, and we're looking for target 1, evaluating numeric expressions and algebraic expressions for a given variable of a number. So if I put in an x, instead of an x, I want it to be 3, I'm going to solve this. So it takes us several days to get there, so I don't want you to be worried about not understanding what that is. Remember, we're taking it one step at a time. Our one step at a time is concentrating on order of operations this week and understanding that the dot means multiply and learning some vocabulary. Okay, speaking of vocabulary, base, power, exponent, perfect square, perfect cube, evaluate, and I'm just going to tell you evaluate means to solve. And then we have order of operations. Those are the words that you're going to be listening for that you pause and put in your glossary. Now, expression. Recall that an expression in mathematics is a number or a combination of numbers and operations. You know what? If you wanted to put that in your glossary, you sure could. An expression. The number 8 is an expression. And 2 times 2 plus 4 is also an expression. Both of them are equal to 8. So if I asked you to find 6 different ways to make 8, we would write expressions like 2 times 4. 10 minus 2, 4 plus 4, 16 divided by 2. Those are all expressions that equal 8. So write an expression that is equal to 10. Now, this says using only 4 2's and any math symbols. I'm going to scratch that. I just want you to use math symbols. That means you can add, subtract, multiply, or divide. I want you to make 10, but I want you to make 10 3 different ways. Okay, so pause the video. Make 10 3 different ways. Raise your hand and let me check. I'm going to keep moving. Here's more vocabulary. So we have a power. Just as repeated addition can be represented as multiplication, that means if I have 2 plus 2 plus 2, that equals 6. I can also write it as 2 times 3 because there's 3 2's, and that equals 6. That's what they're talking about. Repeated multiplication can be represented as a power. So this is somewhere where you would want to stop and put this in glossary. A power has 2 elements, the base and the exponent. Power. Okay, so the number 2 is the base. It's the number here that you multiply by itself. The 4, that little, I call it kind of like a baby floating number, it's the exponent. That tells you how many times am I going to multiply the base. There's 1, 2, 3, 4. We multiplied it times itself 4 times. So there's really 3 vocabulary words there. I want you to think about putting base, power, and exponent all in your glossary. Ooh, I did not mean to make myself that big. You can read a power 2 different ways. 2 to the 4th power, or 2 raised to the 4th power. You want to become a little bit familiar with those ways to say the problem. Okay, so take a moment, get those 3 words in your glossary. I'm going to keep moving. The base of a power is the factor that is multiplied repeatedly. The exponent is the number of times the base is used. Okay, I just kind of explained that to you. For instance, on number 1, identify the base and the exponent. 7 is the base. 5 is the exponent. What does this mean? It means 7 times 7 times 7 times 7 times 7. I had to do it 5 times because the exponent is 5. It says write each power in words. That means I'm writing it 7 to the 5th power because it's got a 5 up there. Okay? Pause if you need to get all that written down. This is super, super important. We are building a foundation. Here's another example. 4 to the 8th power. Where's the base? The base equals 4. The exponent equals 8. What does it mean in words? 4 to the 8th power. Okay, what does it mean in math? 4 times 4 times 4 times 4 times 4 times 4 times 4, that's 7 times 4, that's 8 times. Check me. Make sure I wrote it 8 times. Now, I would never tell you to come up with that number in your head. I would give you a calculator to do that. Okay, never think you're going to have to multiply 4 times itself 8 times without a calculator. Okay, let me move myself here. Now, this is kind of just a review because you're going to see this with some formulas when we go back to area, or as you go to area maybe when you get older. The area of a rectangle, is calculated by multiplying the length and width. Because the sides of a square have the same length, the area of the square, which we use as a capital letter A, is calculated by multiplying the side length S by itself. So if I had a square that was 2 by 2, I know that I would multiply 2 times 2. Well, what they're saying here is, what if I don't know what the side length is and I'm just going to label an S that stands for side? I would multiply side times side, which is side with a baby floating 2 squared. Okay, so let's take a look at this. Write the area of each square as a repeated product. That means repeated multiplication. Well, I know the area of a square is going to be the side length times the side length. What's the measurement of the side? 9 times 9. Your new way to write this would be 9 squared. We multiply 9 by itself 2 times. Okay. This is what we call a table of cubes. Okay, so I can do this with squared numbers, but I can also do it, hang on, I want to move this right here. Okay, so this is probably on a different page from you. Okay, so don't worry about that. You'll find it in your packet. It's kind of out of order, so don't worry about it. I'm moving it right now as I go, so don't worry about it being out of whack on yours. This is a list of squares. So we were just talking about squares. It's helpful to become familiar with these. So if I square the number 1, it's 1. That means 1 times 1 is 1. 2 times 2 is 4. 3 times 2 is 9. So I just put this in here so you are familiar with some of these, okay? It might be kind of a challenge to kind of memorize these. Now, perfect squares, here's another vocabulary, because they are squares of an integer. For example, 9 is a perfect square because 3 times 3 is 9. So you're looking for the answer being a perfect square. Another way to write this mathematical sentence is 3 squared equals 9. Okay, now similarly, we can have a thing called perfect cubes, or S cubed to the 3rd power, because when we deal with volume of a cube, remember all the measurements are the same, but volume is length times width times height. So we have to do side times side times side, or side cubed. For example, here's my cube. So ordinarily, to find the volume, I would take 2 times 2 times 2. Now you know a new way to write that. That's 2 to the third power, or 2 cubed. Now remember, I switched these around, so this is going to be up higher in your packet, but these are common cubes that you would use in your mathematical career. Okay, I put these in here so you could feel, just kind of get an idea of what this means, kind of a reference point to check yourself. If you're working a problem where you have to take 3 cubed, know that it's 27. It's not 9, it's not 3 times 3. It's 3 times 3 times 3. A perfect cube, just like a perfect square, is going to be the answer. So I know 6 cubed is 216. So 216 is a perfect cube. Okay, and you'll work more with those as you get older. Okay. Now the next part is going to be a little bit longer. I'm going to go ahead and stop the video now because I don't know if I can get it done in the 15-minute requirement. So you can go ahead and keep going to your next video, but I'm going to start a new one.